In this chapter, we will learn that what are the different types of plastic materials are used in the engineering applications, and what are the different properties of those plastic materials, and what are the different types of manufacturing processes can be used in type of for making these plastic parts or plastic products. So first we need to know what is polymerization. So basically, the polymerization is a process where small organic molecules, which is termed as monomer, are stitched together to form a long chain, and that long chain is called as a polymer. So this process is called as polymerization. Now it is necessary for a monomer to be at least bifunctional, means it should have a capability of forming two covalent bonds to polymerize. Now some monomers are polyfunctional, which have the capability for of forming three or more bonds. Now this polymerization process is classified as two types. One is addition polymerization, another one is condensation polymerization. Now addition polymerization consists of breaking the double carbon bond in bifunctional polymers so that the chain can be formed. Like, for an example, suppose ethylene, when the ethylene is polymerized, it will be called as polyethylene. Now next one is the condensation polymerization. In condensation polymerization, two different organic molecules react to form a plastic molecules. For an example, suppose the adipic acid is reacted with hexamethylene diamine, and it will produce nylon 6,6 plus H2O. So H2O will be produced as a byproduct. Okay, so in this reaction, generally the H2O comes as a byproduct, and the the plastics made via the condensation polymerization, the plastic can get degraded when it will be exposed to water and high temperature. So these are the limitation. This is the limitation of a condensation polymerization. Next is the properties of plastic material. Now the first is the density. So the plastic materials have relatively low density compared to the metallic materials. So that is a advantage. And the plastic materials, the next property of the plastic material is the strength of the plastic material. Now this plastic material has a very good strength to weight ratio. So the plastic materials show both elastic and plastic behavior depending upon the temperature. So they are generally good in compression, while under tensile loading they do not exhibit sufficient strength. So the designers of the plastic products and that experience tensile loading have to develop the geometries with high stiffness. Now the strength of plastics in tensile loading can be greatly increased by reinforcing with appropriate fiber in the required directions. Next is the toughness. So the toughness of plastic materials has a wide range. There are some plastic materials such as polycarbonate which are unbreakable, and the plastics becomes brittle if they are subjected to sub-zero temperature and or contain severe stress concentrations such as sharp corners, and knots. Next is the viscoelasticity. Now, the viscoelasticity, this property is the plastics which is under the short term loading with low deflections and small loads at room temperatures behave elastically like a spring and returning to their original shape when the load is removed. So, no energy is lost or dissipated during this purely elastic behavior. Now, they also exhibit a viscous behavior under a long term heavy loads or elevated temperatures, while still solid plastics will deform and flows similarly to a very high viscosity liquid. Okay, next property is a creep. So creep is a time dependent property, means it is the deformation which occurs over time when a material is subjected to a constant stress at elevated temperature. Okay, so these are the properties of a plastic material. Next, the what are the different types of additives can be used in plastic? So the first additives, so basically why these additives are used? A number of additives are normally used with plastic materials to modify their behavior, improve properties, or reduce the overall cost. Thereby, it increase the range of application of the plastics. Now, the first one is the plasticizers, which are mixed with plastics to improve their flow characteristics, and it decreases the brittleness. So, these are the liquid organic compounds with fairly large molecular weight, and the glass transition temperature is a temperature at which an amorphous polymer becomes brittle on cooling or soft on heating. Now, the plasticizers, what this plasticizer will do, it will lower the glass transition temperature, thus, it will help the plastic to get softer and more flexible at the room temperatures. So, for example, suppose there is a polyvinyl chloride which is brittle at the room temperature, but when the plasticizer such as diisoctile is mixed with PVC, then the PVC will become flexible and it can be used as a wrapping tape for electrical insulations. Next is the filler material. Next additive is the fillers. Fillers are inexpensive material and these can be used or these can be added to the plastics to reduce their cost. So many of the filler materials increase the hardness and impact strength of the plastics. There are common filler materials like quartz, glass spheres, talc, calcium carbonate. These are the common filler materials that can be used in the plastic material. Next is the flame retardants, which are added to plastics to reduce the flammability of the plastics by preventing oxygen reaction. Next is the reinforcing agents. The reinforcing agents are the materials that are specifically added to plastic materials to raise the mechanical properties. The last one is the stabilizers. The stabilizers are used to stabilize the properties of the plastic throughout its useful life, and they resist heat, strength deterioration, and reduce the effect of radiation on bonds within the chains. Next is the different types of plastic materials. Basically, the polymeric materials are classified into two types. One is the plastics, another one is the elastomer. Now, the plastics are further classified as thermoplastic and thermosetting plastic. Now, the thermoplastics are classified as commodity plastics and engineering plastic. Similarly, the thermosetting plastic is also classified as commodity plastic and engineering plastic. Now, under the thermoplastic, under the category of commodity plastic, the plastics are or the examples are polyethylene, polypropylene, polystyrene, PVC. These are the different types of examples. So these what is this thermoplastic materials? Basically, the thermoplastic materials are the materials which are or which can be softened and melted by heat and can then be means it can be the shape can be given to the plastic materials when it is hot. And these materials, suppose you need to change the shape of the materials, then again the material can be heated and again we can give the other desired dimension, the other desired shape. That means that we can recycle the thermoplastic materials. Okay, now another one is the thermosets. Now the thermosets are the materials which means suppose after manufacturing of the thermosetting materials, then if we cannot recycle the products. Okay, so these are the plastics that cannot be melted once they are solidified. The raw materials for thermosetting materials are usually called as resins, and which are mixed and placed in the mold and heated and compressed, during which process the materials achieves the strength and hardness. And the polymerization occurs by strong network bonds with the application of heat, pressure, and time. The cross links between neighboring polymer molecules limit chain movement, and these materials could not be recycled until recently, means after the products after the solidification, then we can use the thermosetting materials, but we cannot recycle it, means we can it cannot be further heated and again it cannot be give the shape to the other desired shape. Now when the materials are heated, these materials burn, and as a result we cannot use this material for the further use. The thermosetting materials degrade rather than soften when exposed to excessive heat. Okay, so there are some of the common thermosetting materials are like phenolics, alkyds. These are the some commonly used thermosetting materials. Now under the thermoplastic materials, the popular materials are, first one is the polythene. Now this polyethylene is the major advantage of this polyethylene is its resistance against many acids and bases and its flexibility. Now it has some limitations also. The limitations are it means it has a low strength and low heat resistance compared to the other engineering polymers. Also, its mechanical properties degrade when it is exposed to certain environments such as ultraviolet radiations from sunlight. So these are the limitations of the polyethylene. Next, for the polypropylene, these polypropylenes are used for luggage, battery cases, and toolbox manufacturing because it has a low weight. Carpets and ropes are the other uh, are the other products of this polypropylene. Next is the PVC, or it is also called as polyvinyl chloride. Now this polyvinyl chloride are widely used in the application for the piping. The main limitation of PVC is its low toughness and notch sensitivity. That is the limitation of PVC. Next is the polystyrene. Now this mm, out of the total usage of the different plastic materials, there are mostly used plastic material is the polystyrene. Okay. Now it has a poor, it has a but there are some limitation of this material, that it has a poor impact strength, and as a result it is not used in the engineering plastic because of its low cost. The widest use of it is in throwaway items such as plastic tableware and food containers. These type of materials, those type of products are generally made by this polystyrene. Next is the polymethyl methacrylate. Now what is this one? So it is, it means it is a clear and rigid, and it is used for side glasses, machine guards, windows, low cost lenses. These are the different types of applications. Next is the polyamides. This is which is under the category of engineering plastics, and these are commonly referred to as a nylon. With there are variant types, there are different types of nylons are there. Nylon 6, nylon 11, and nylon 12. Okay. Now this nylon is crystalline thermoplastic with very high mechanical properties compared to other thermoplastics. One major problem with nylon is the moisture absorption. Now, with moisture absorption, the tensile strength is reduced and the dimensions increase. So, nylon is a widely used engineering plastic for parts such as gears, cams, uh, slides for machineries. Okay, so these are the different types of applications of polyamides. Next is the polycarbonates. These are amorphous polyesters with good transparency, excellent moldability, and high impact strength. And they are more expensive but preferred in applications where high impact strength is desired. So these are the different, and these are the mostly used plastic materials that we have discussed. So these are thermoplastic materials, as we have already discussed the thermoplastic materials. Now these are the properties of the thermoplastic materials, like high strength and toughness, better hardness, chemical resistance, durability, self lubrication, transparency, and waterproofing. These are the different types of thermoplastic materials that we have discussed right now. Next is thermosetting materials. These are the different types of thermosetting materials. This one will be the types of thermosetting materials instead of thermoplastic materials. So you just edit this one, that it will be thermosetting materials. Now the structures of the plastics. There are four types of structures are there in the plastics. One is the linear type of structure, like nylon, PVC, which have the linear structure of the of the monomers. Next is the branch structure. Next is the cross-linked structure, and another one is the network structure. So these are the different structures of plastics. Now there are different manufacturing processes are there for the making of the plastic products. Now among those different manufacturing processes, and first important process is extrusion, and the output of this extrusion process is called as extrudate. So what is this extrusion process? So extrusion is a process of confining the material in a closed cavity and then allowing it to flow only one only one opening, so that the metal will take the shape of the opening. That is the concept. So this operation is quite identical to the squeezing of toothpaste out of the toothpaste tube. So what is the important characteristics? What should be the important characteristics of the material? Now, to have the final shape similar to the final product, the material should have a characteristics. So the characteristics that often differentiate this extrusion process from the injection molding process, or the extruded plastics from the injection molded plastics, is the viscosity of the plastic at normal processing temperatures. Extruded plastics often have a higher melt viscosity that allows the extruded to retain the shape imparted to it by the die while the extruded is in the cooling stage. Now it is possible to combine a variety of resins to gain special physical, biological, or chemical properties. The additives can be used. Now, additives that include lubricants, thermal stabilizers, antioxidants can be used during the extrusion processes to enhance processing characteristics of the polymer or to alter product properties. Now, the plastic that is generally in the form of pellets or granules is fed into the extruding machine through a hopper. Now, this machine is known as a extruder, or it is called as a plastic extruder. Now, the pellets move into the barrel by gravity. The barrel is heated by electric heater, which softens the pellets in the barrel. Now, the screw moves the pellets continuously, and the mechanical working and the friction present generate more heat to soften the plastic. Now, the heating of the barrel may be reduced once sufficient heat is supplied. The rotating screw has three main sections. One is the feeding section or the feed section, another one is the compression section, another one is the metering section. Now, in the feed section, the pellets are moved from the hopper and preheated, and in the compression section, the plastic is softened sufficiently so that it will flow smoothly like a liquid. Now, finally, in the metering section, the plastic is completely homogenized and sufficient pressure is developed so that the material will be forced through the die. Now, the feeding capacity of the screw is determined by its geometry and speed of rotation. Now, there is a breaker plate which have several small holes. It is in between the die and the barrel, which will improve the mixing of the plastic before entering into the die. The extruded product called extrudate is cooled by blowing air or by passing through a water filled channel. Now, the die is metal plate placed at the end of the extruder with a cut out of the shape of the cross section of the product being manufactured. And any complex external contour can be extruded with relatively simple and inexpensive toolings. That is the specialty of the extrusion process. Now, we can produce the plastic products like a solid extrusion. Means this is a process that is similar, means the process that we have discussed right now, that process is called as solid extrusion, where the cross section is a uniform cross section. Now the extrusion can be a hollow extrusion. So this process is used to extrude parts that have hollow cross sections such as pipes and tubes. Okay. So these are the different types of extrusion processes are there. Now there are few advantages of the extrusion process. Like the first one is equipment is simple and it is relatively inexpensive. Next is the low tooling cost, and the last is overall cost of the parts produced is low. Okay, so this is the extrusion of the plastic process.